Hello, this is the luckiest maths teacher in the world. Thank you so much for watching. Today I'll go through the gradient, and we're talking about the gradient of a line because we're doing linear functions. So the gradient is also the slope of the line. So you know when you're like walking up towards a hill, you might say, oh, the hill's really steep, or the hill's, really flat or whatever. That's basically what we're doing here. When we're looking at the gradient or the slope, we're looking at how steep or flat the line is. Now, in maths, we like to put everything in numbers. So we want to give the gradient or the slope a measurement. We're going to give it a number that allows us to compare the steepness of lines. So what actually is the gradient? It is sort of a measure of how fast the line is going up. So let's have a look at an example. So in the Cartesian plane that you see on your screen, I've just drawn a line. And this is very similar to all the lines, all the linear functions you would have seen in the last lesson. So the way that we measure, the way that we quantify, put into numbers, the gradient of a line is rise, which is how far it goes up, and run, how far it goes across. And we usually call that M. Another way to look at this is this little triangle here means change. The change in Y, which is how far it goes up, over the change in X, how far it goes across. So what you're essentially looking for is 2 points along the line, and you want to see how fast the X values change between those points, and you want to see how much the Y value has changed between those points. So if we look at, say, this point and this point, to get from here to here, and I believe you should always start on the leftmost point just to make things easier. So I'm going to start here at this point, and I'm going to go to this point. So how do I do that? I need to go across by 2. So that means that the run is 2, and I need to go up 2 as well. So the gradient, how far I've gone up 2, I've gone across 2, the gradient is 1. What that means is each time I go across 1, each time the X value increases by 1, the Y value also increases by 1. So it doesn't really have that much meaning in and of itself that the gradient is 1, is that a steep line or a flat line, but it allows us to compare other lines. So let's have a look at another type of line. So let's now look at the line in black. We're going to find its gradient. So again, I've marked 2 points, one here and one here. So we'll start at the point on the left-hand side, and we'll go to the one on the right-hand side. So how do we get from the first point to the second point? We have to go across 2 again. So the run is 2, but this time we have to go up 1, 2, 3, 4, 5, 6. This time the rise is 6. So the gradient of the first line, I'll call that M1, was 1. The gradient of the second line is 6 for the rise, 2 for the run, 6 over 2, which is 3. So again, the gradient being 3 doesn't have that much meaning in and of itself in terms of the steepness, but it allows us to compare the steepness. It allows us to show in numbers this line is steeper than this line because it has a higher gradient. So higher gradient means the line is steeper, it means that it's more vertical, it means that it goes up quicker. So the gradient of 3 means that every time we increase X by 1, we increase the Y value by 3. So every time we go across 1, we have to go up 3. Now the thing about linear functions is they have a constant gradient. They have the same gradient everywhere along the line. So I did pick this point and this point, but it should work for any points, notwithstanding my poor drawing, and I do apologize for that. So it should be anywhere that I can just pick any point on the line, go across 1, and then I should go up 3, and then I should be on the line again, okay? So the gradient is the same everywhere on top, everywhere along the line, okay? I need to show you one more type of line. So let's now look at the line in green. So hopefully you can see, even before we calculate the gradient, that the line in green is flatter. It's less steep than the white line and the black line. Hopefully you've also realized that this line is actually facing the other way. The black line and the right line, they're leaning to the right. What I sort of mean by that is, think of a vertical line. The line can either be tilted to the right and look like that, or it can be tilted to the left and look like that. So the original black line and the white line, they are both leaning to the right. The green line's leaning to the left. So if the line leans to the right, that means that the gradient, m, is greater than 0. Gradient is positive. And we saw that in the previous two examples. Both of them had a positive gradient. When the line leans left, the gradient is always negative. So for this green line, I'm going to expect that it has a smaller gradient than 1 because it's flatter than the white line. I'm also going to expect that the gradient is negative because it's leaning to the left. We do this the same way though. We calculate the gradient the same way, rise over run. So let's look at the gradient of this line. So I'm going to start at the leftmost point again, and I'm going to find another point on the lines. How do I get from here to here? So this time I go across 1, 2, 3, 4 to get to the other point. So the run is 4. But instead of going up to get to the second point, I need to go down. So I've gone across 4 and I need to go down 2. So I'm going to put a 2 for the rise, but because I went down, I put a negative there. Negative 2 means not that I've gone up, it means I've gone down. A negative rise means I've gone down. And negative 2 over 4 is just negative a half. Okay, so the gradient doesn't have to be a whole number, it can be a fractional number. And that's what a gradient of negative a half means. It means for every 2 I go across, I go down 1. The reason I go down is because it's negative. If the gradient was positive a half, it means every time x increases by 2, I go up 1. Y increases by 1. But here, when we went across, y has decreased. It's gone from 2. Y value here at the first point is 2 and at the second point is 0. So y has gone down. So that is how we find the gradient when we're given the graph of a line. So always start at the leftmost point and always go to the right, so that what I just did, you can do as well. Meaning that it will be easier to determine whether the line has a positive or negative gradient. Because if you always go right, if you always start at the leftmost point and go to the right, then it's easy to determine whether the gradient's positive or negative, because if you then go up, the gradient is positive. If you then go down, as we did with the green line, the gradient is negative. All right, I just need to show you how to find the gradient when we have not the graph of the line, but 2 points. So please pause and copy this down if you need. So because this is how we find the gradient when we're given 2 points rather than the graph, we need to use the 2-point formula. Note, you can still use this when you've given the graph, it's just a little more complicated than what we just did. So this is the 2-point formula. So you need 2 points. We label them x1, y1, so the x coordinate of the first point, y coordinate of the second point, and x2, y2. You need 2 points. You can't have just one. So m, the gradient, is the rise, which is, as I said before, the change in y values. So the distance between the y values can be calculated just by subtracting them. And same for the x values. So y2 minus y1 is the rise, x2 minus x1 is the run. This rise is how far we've gone up, the change in the y values, the distance between the y values, and this run, x2 minus x1, is how far we've gone across, the change in the x values or the distance between the two x values. So for example, let's say I have a line that goes through the points -1, 7 and 4, 5. So I'm now going to calculate the gradient of this. Now note that there is one and only one line that goes through those 2 points, so I can calculate the gradient accurately. So we label our points. You don't have to fully write this out, but I'm just going to do it to show you. So first point, x coordinate, y coordinate. Second point, x coordinate, y coordinate. And then we just use the formula. Gradient equals y2 minus y1 over x2 minus x1. So make sure you don't make mistakes with negatives there. It's 4 minus minus 1, because this is minus 1, is the x-coordinate. So 5 minus 7 equals minus 2. 4 minus minus 1 is positive 5. The gradient here is negative 2 over 5. So what that means is the line will be a little flat. It means that between 2 points, if you go, for every 5 you go across, you go down 2. So that's what the gradient means, and we've managed to calculate it even without a graph. Alright, hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.